Hi, this is Mr. Heineman from Evergreen High School. This is for my Algebra 1 students. This is from Unit 6, Rational Exponents, and Radicals. We're going to begin by talking about radical expressions, and then we'll connect those to rational exponents. So radical expressions, when you look at these expressions, what patterns or similarities do you notice, and how are these expressions different? So here are the expressions themselves. I would encourage you to pause the video right now and be able to answer these two questions. What you probably noticed about these expressions, and they all have the same format. They have this radical symbol, which is what this little symbol is called, and they have a number right here. So they have this symbol, we call it a radical, and then they have some number. Inside the x is, like we learned with exponents, is called the base. And then when we use the radical, we give a name to the little number, we call it a root. So all of these are expressing roots. So third root, fourth root, 10th root, 7th root. When we have just this one, this is the square root, or to the second power. There's no 2 there, but we assume there's a 2 there. So now, if we look at these expressions, we're going to connect them to rational exponents. So here we see some of our radical expressions along with some rational exponent expressions. And what your job is to do is to match the radical expression on the left to the rational exponent expression on the right. So again, I would ask you to pause the video for right now, write these down in your notebook, and then make the connections between the two sides. In making the connections, what you should have noticed was that the third root connected to the x to the 1/3, and the 10th root connected to the x to the 1/10, 7 with the 1/7, and then the last one, even though there's not a 2 there, we connect it with the x squared, and that's because we assume that there's a 2 here, even if there isn't. So sometimes it's helpful to write the 2, but you should know that if there's no root there, then that would be considered a square root, which is the second. And it goes with x to the 1/2. So to formally define the rational exponent property, when the exponent of a base is rational, you can rewrite it as a radical using the denominator of the fraction as the root. What that looks like in symbols is b to the 1/m becomes the mth root of b, and that's how we say it. So we would rewrite it from this rational expression where we have 1/m to use a radical with a base of b. It's the same base, and the root is m. So when it comes to using the rational exponent property, if we're given a rational exponent like x to the 1/11, we can rewrite that using a radical instead, where 11 is the root, and then we just write our base inside. If we're given the radical expression instead, well, we can go the other direction with that. Just like any of the other properties, we can rewrite this as x to the 1/8 as a rational exponent. For the most part, rational exponents work just like any other exponents. if I see two things in here, I can put them both actually inside of one radical. Now there's a little bit different here in that if we have things with the same radical, we can put them all in one radical. Instead of 1/3 to both of these, we can just put the whole thing inside of one radical. And then finally, if we're given a number, just like we did with exponents, we should calculate what that number is. So I could put the square root of 25 into my calculator, and I would get 5.